May 31st, 2013, El Reno, Oklahoma. The air was thick, charged with tension. The sky shifted to a sickly green-gray, a warning Oklahomans know too well. Clouds boiled and churned, signaling a storm of historic proportions. Weather alerts blared, meteorologists watched in dread, as a supercell thunderstorm took shape. This wasn't just another spring storm, it was a monster in the making. The atmosphere was unstable, the wind howled, and an eerie calm settled. A real calm before the storm. Families rushed to shelters, knowing the sky demanded respect. The storm was a living engine, fueled by colliding warm, moist air from the south and cool, dry air from the west. The clouds towered, forming a massive anvil shape, electricity crackling inside. Hail the size of baseballs formed, and the world seemed to hold its breath. Birds fell silent, and the landscape braced for impact. This was more than weather, it was nature's raw power, ready to strike. The people of El Reno prepared, but nothing could ready them for what was coming. The stage was set for one of the most extreme tornadoes ever recorded. The sky was about to unleash its fury. El Reno sits in Tornado Alley, where geography and climate create the perfect storm. The flat plains offer no barriers, letting storms grow unchecked. Warm, moist air from the Gulf of Mexico collides with cool, dry air from the Rockies. This explosive mix creates powerful updrafts, the engines of thunderstorms. Add wind shear, and the air begins to spin, forming a mesocyclone. Supercells, rotating storms, are born, capable of producing the world's most violent tornadoes. Oklahoma, Kansas, Texas, and Nebraska see these storms every spring. On May 31st, 2013, the ingredients weren't just present, they were supercharged. The atmosphere was primed for disaster. Tornado Alley storms are legendary, but this one would be historic. The people were prepared, but nature was about to test every limit. The perfect recipe for a record-breaking tornado was complete. That afternoon, the atmosphere over Oklahoma was explosive. Cape values soared above 5,000, off the charts for instability. A dry line triggered the first storms, forcing moist air skyward. Powerful wind shear twisted the updrafts, birthing a massive supercell. On radar, a hook echo appeared, the classic sign of a tornado forming. The storm produced giant hail, relentless lightning, and a terrifying rotation. The National Weather Service issued dire warnings. Life-threatening, complete devastation possible. Storm chasers and scientists converged, drawn by the storm's power and the chance to gather critical data. Among them were the most experienced researchers, ready to face the unknown. The supercell was a monster, its size and intensity unprecedented. No one knew this tornado would rewrite the rules of storm chasing. The chase was on, but the danger was greater than anyone realized. The supercell unleashed its fury. A funnel cloud touched down near El Reno. It grew rapidly, morphing into a 2.6-mile-wide wedge, the widest tornado ever recorded. Its size dwarfed Manhattan, and its rain-wrapped form made it nearly invisible. Many didn't recognize the threat until it was too late. Inside, winds topped 300 miles per hour, among the fastest ever measured. The tornado's path was erratic, shifting directions without warning. Subvortices, smaller tornadoes within the main vortex, spun at incredible speeds, causing focused devastation. The storm's complexity made it unpredictable and deadly. It wasn't just a tornado, it was a chaotic, multi-vortex beast. Even seasoned chasers struggled to comprehend its scale and power. The El Reno tornado was unlike anything the world had seen. Scientists and storm chasers risked everything to study the El Reno storm. Their mission: understand tornadoes to improve warnings and save lives. Tim Samaras, a legendary chaser, led the TwistX team, deploying probes directly in tornado paths. On May 31st, 2013, Tim, his son Paul, and colleague Carl Young tracked the supercell, aiming to gather groundbreaking data. Roads filled with chasers, emergency vehicles, and fleeing residents. The tornado's size and unpredictable path created chaos. Escape routes vanished in moments. Even the most experienced chasers found themselves in danger. The storm's erratic movement turned the pursuit of knowledge into a fight for survival. The TwistX team, dedicated to science and safety, faced the storm's full wrath. The line between research and risk had never been thinner. The tornado's sudden turn trapped chasers and residents alike. The TwistX team's car was caught in a violent subvortex. Tim, Paul, and Carl lost their lives. Their deaths shocked the meteorological world. If it could happen to them, it could happen to anyone. The storm claimed 8 lives in total, many caught on the roads, unable to escape. The tragedy raised urgent questions. Shelter in place or flee? For a storm like El Reno, the roads became a deadly trap. The community suffered immense loss, homes destroyed, lives upended. The scars, both physical and emotional, ran deep. The El Reno tornado was a collective trauma, its impact felt far beyond Oklahoma. The El Reno tornado forced a reckoning in storm chasing and public safety. Chasers adopted stricter safety protocols, prioritizing distance and caution. The loss of the Twistex team underscored that no data is worth a life. Scientific data from the storm revealed the complexity of tornadoes, leading to stronger buildings and better shelters. Public warning systems evolved, emphasizing shelter over evacuation for most situations. The event changed how emergency managers advised the public, aiming to prevent deadly traffic jams. El Reno rebuilt, but the memory of May 31, 2013, endures. The legacy of Tim Samaras and his team inspires new generations of scientists. From tragedy came knowledge and a renewed commitment to safety. The El Reno tornado stands as a testament to nature's power and the resilience of the human spirit.